Spontaneity. A spontaneous reaction is a reaction that happens naturally without the intervention of any external factors, and which pushes a system towards its equilibrium. For example, a ball will easily roll down a hill without effort, but will never roll back to the top on its own. It's important to take note that spontaneity is not dependent on speed. A spontaneous reaction can be extremely slow. Spontaneous simply means that a process takes place. The right answer is the formation of rust on iron. To bake a cake, we need to add heat, which means the reaction is not happening spontaneously. To run a marathon, a very large quantity of energy in the form of ATP is required. And to melt ice at a temperature of -5 degrees Celsius, we have to either add heat or another chemical substance. The formation of rust is an oxidation reaction that happens spontaneously, even if it takes a long time to observe. Similarly, heat can be transferred spontaneously from hot to cold, but never in the opposite direction. On a more biochemical note, the transportation of certain molecules across different biological membranes happens by diffusion, so spontaneously. However, in other cases, transport proteins are required to carry out the work. Here's the formula for the Gibbs-free enthalpy change. We can determine a process's spontaneity by the value of delta G, the Gibbs function. Spontaneous reactions have a negative value of delta G, while non-spontaneous reactions have a positive value. The inverse of a non-spontaneous reaction is a spontaneous reaction. In this question, where delta H is positive and delta S is negative, here's what the Gibbs-free enthalpy equation would look like. Since the temperature in this equation is in kelvins, it will never have a negative value. Therefore, since we have a subtraction of T times delta S, and delta S is negative, we will always end up with plus T times delta S, because the two negatives will cancel each other out. Since delta H is positive, this means that our reaction will never be spontaneous, because no matter what values we put in for temperature, we will never get a delta G value of less than 0. This reaction has a negative delta H and a positive delta S. We want to find out in what situation our reaction is spontaneous, so our value of delta G must be negative. Again, our temperature will always have a positive value, so T times delta S will always be positive, and delta H is negative. Subtracting a positive number from a negative number will always give a negative value, so our reaction is spontaneous no matter what the temperature is. The Gibbs-free enthalpy equation looks like this. We can't just look and see right away what the value of delta G will be. This time it depends on the temperature. At a low temperature, T times delta S will have a fairly small value, so subtracting its product from delta H will allow for a positive value of delta G. Therefore, the reaction is non-spontaneous. At high temperature, T times delta S will have a value greater than delta H, so the subtraction will give a negative number, meaning that our reaction is spontaneous. So, the reaction will be spontaneous as long as we have a high temperature.